are just going to discuss the topic of PIC microcontroller. It is an evolution of PIC microcontroller and the embedded process. And this is the block diagram of PIC microcontroller. PIC is the Peripheral Interface Microcontroller, which is developed in the year 1993 by the General Instruments microcontrollers. It is controlled by software and it has been programmed in such a way that it performs a different task and it controls the generation line. And this is the architecture of the PIC microcontroller. The term PIC stands for Peripheral Interface Controller. These 8-bit microcontrollers have become important nowadays in industrial automation and then embedded application process. And it has been built by upgrading low-end architecture with more number of peripherals, more number of registers and more data or programmable. There are many PIC available in the market. It has been ranging from PIC 16F84 to PIC 16C84. So F and then C in this middle of this PIC 16F, like it has been a fast one or C, something like these type of PIC microcontrollers are these types of PIC are affordable for the flash PICs, and it is the Microchip has recently introduced flash chips with different types such as 16F28 and then 16F877A and then 18F452. So this cost wise and all it has been depends like it differs from one type to another type, and it has more code size with more RAM also, and then much more input output pins and UART and A to D converters and lot more features are there in the case of PIC microcontroller. Here we can see like input output ports are from port A to port E, from port A, B, C, D, E. That is for all the ports it is not the pins are equal. Only for 3 ports it is the pins are equal, that is 8. And the remaining thing one has 3 pins and another one has 5 pins. So total you will be having 5 ports. The oscillator SPI is nothing but serial peripheral interface, and then USART is universal synchronous asynchronous receiver transmitter. And timer we have timer 0, timer 1 and then timer 2, 3 timers we have, and power supply we have 2 to 5.5. Here the special function registers SF are the status registers, arithmetic and then logic, and then unit and then input output port, timers and then A to D converters. Here the input output ports are like the microcontroller controllers have multiple input output ports like port A, port B, port C, D and then E. Each pin with the port can be configured as either as an input or an output. The timers and the counters are like PIC includes one or more timers, that is timer 0, timer 1 and then timer 2. We have 3 timers. In this 3 timers you will be it is also acts as a counters. So if the timers is equal to 0 means the counter will be enabling, and if the counter is 0 the timer will get enabled. Okay, this is the main simple thing. So the next thing is like a status register. What is status register? The special function registers, which is also includes the status register. These register control the specific functions of the microcontroller such as input, output ports, etc. Here we are having a general purpose registers also. In this the direct addressing and then indirect addressing mode. So two things are there. In this general purpose register in the block itself, it is saying like the registers on the CPU that can be used either in a memory address or data as and when they are in need. An example it would be to store the current register contents when there has been, if there is any interrupt. If it is there, the general purpose registers obeys. And next one is fixed status registers. We have already seen like what is the status register from B0 to B7 means we will be totally having 8 pins. So here C, DC, Z, OV and then N is nothing but these are all the flags which has been set based on the application or based on the operation you do. So it is an 8-bit register. It is also referred to as a flag register. Here it is an 8-bit wide. Only 5 bits of it is been used by the PIC 80 and the 3 unused bits are unimplemented and it has been read as 0. or 14 KB of flash memory, program memory, 368 bytes of RAM and 256 bytes of EEPROM, 8 channel 10-bit ADC and USART, SPI and I2C. That is I2C, SPI, USART and all. It is the protocols. So I2C is the inter-integrated protocols. The big common directives are EQU and then origin, DS, DW, DB and all. It is there. Like RES for reserved for something else and EQ is for equate and ORG is on origin and configure hash include end and all. It is a directive one. It is being used with your program. This is simple classroom activity for funds for fun. It is for students and then the assessment is we have object oriented questions like first questions to what is the function of peripheral interface and then what is the purpose of watchdog timer. Thank you. We'll see the next topic in the next video.